Okay, so this is station 2 for absolute value equations. What we're going to do is we're going to work through a problem together. You're welcome to take notes on it or just to simply sit and watch. It's up to you. And then I'm going to ask you guys to pause the video and work a problem together as a group. See if you come up with the right answer. Figure out where any miscommunication or errors may have been made, and then we'll move on to a new station. Okay, so in total about 10 minutes. Okay, the problem that we are going to work together is as follows. Okay, it is going to be the absolute value of 7p plus 7, close absolute value bars, minus 8 equals 34. Okay, now the first thing that we always wanted to ask ourselves was, is the absolute value box alone? So right here is my box that you can see, and of course on this side of the equation it's not alone. Here's my equal sign because it is being bothered by this negative 8. Okay, you always want to check and make sure that your order of operations is done on both sides before we do anything, and we want to go forward. So of course we want to see, do I need to simplify parentheses? No, there's no exponents. There's nothing to add, subtract, multiply, divide. I can't subtract that 8 from my absolute value here because I can't change anything on the inside of those absolute value bars. So that's all correct. There's nothing that I can do to simplify this. So now I want to go and do my order of operations backwards. I want to get my absolute value here alone, and that's going to require me to get rid of this negative 8. And of course, the opposite of subtracting 8 is going to be adding 8. So let's go ahead and do that to both sides. Make sure you keep in mind where your equal sign is at, so you do it on both sides and not twice on one side. Okay, it does happen. And that's going to leave me with the absolute value of 7p plus 7 is equal to, let's see, how about 42? My math is correct. Okay, so all I had to do here is actually one operation to get my absolute value by itself. Now I got to make sure that's equal to a positive number, because if not, my distance cannot be negative. So the distance of everything inside of my absolute value bars is a positive 42. Not a problem. Let's slide this down just a little bit. Okay. And let's go ahead and start to solve this. I need to set up my two equations. Okay, so my first equation is always exactly as it looks. You never ever change what's inside of your absolute value bars. Okay, so there's my first equation. My second equation is going to be very similar. Okay, never change what's inside of the absolute value bars, but you're going to negate, sorry, my zoom is messing up here. Sorry. Let's go back up here. Let's find our problem. There's our problem. Okay. You're going to negate the 42. So it would be a negative 42. Okay. Now I'm going to solve these two equations. Okay. They're both linear equations from chapter 1. We just need to figure out what value will make p true for the first one, what value will make p true for the second one. Okay, so for this first one here, can't simplify anything left or right, so I need to start my order of operations backwards. Subtract 7 from both sides. I end up with 7p equals 35. Okay, and then I look and see, okay, the 7 and the p are being multiplied, so if I undo the multiplication by division, that's a fancy 1. That's going to leave me with p equal to 5. And that should be one of the correct answers. We're going to check that here in just a second. Okay, let's go ahead and do the other equation. Okay, can't simplify anything through my order of operations, nothing to combine or anything, so I'm going to go ahead and start doing my order of operations backwards. I'm going to subtract 7 from both sides, and I get 7p equals negative 49. Okay, and then again, I see that 7 and p are being multiplied, so to undo that, I go ahead and divide both sides by 7, and I should end up with p equal to negative 7. Okay, now the one thing that I want you guys to pause and really take a look at here is my two equations. Okay, if you look at this first equation, number 1, okay, the first thing that we did was we got rid of the positive 7 by subtracting it. Okay, look over here at equation number 2. The first thing I did to get the 7p alone is subtract the 7. We did the exact same step as the first step in both equations. Okay, look at the first equation here, 7p equals 35. Okay, we divided both sides by 7 to get p by itself. Guess what? Look over in the second equation. I did the exact same thing. We divided by 7 to get p by itself. They ended up being the exact same steps. Subtract 7 from both sides, divide 7 from both sides. But we got two different answers, and it's all because we had a positive 42 and a negative 42. Okay, now let's go back and check these answers real quick. Okay, I'm going to slide over here for a second. Slide up here. There's my original problem, okay, that we started with. So let's go ahead and just check these real quick. Let's see if I can, we'll do this in black. Okay, so I end up with the absolute value of 7p plus 7 minus 8 equals 34. So I'm just going to go ahead and check these real quick. Let's go ahead and check 5. 7 times 5 is 35, and 35 plus 7 should be 42. Okay, I'm going to have the absolute value of that, take away 8, equals 34. So I get 42 minus 8 equals 34. And we say 42 minus 8 is 34. So of course that works, and it is true. Not a problem. Okay, let's slide this over just a little bit, and we'll check negative 7 on the other side here. We'll take the exact same equation, but this time we'll put negative 7 in. So I'm going to get the absolute value of 7 times negative 7 is negative 49. Plus 7 gives me negative 42. Close my absolute value. We're going to have to take away 8 from that, equals 34. Okay? Absolute value makes everything come out positive. Minus 8 equals 34. And yes, 34 equals 34. So the answer to this problem is going to be 5 and negative 7. And again, look at when I check, the only difference here is that inside of the absolute value I had a 42 and a negative 42. But in the end, they both came out to be a positive 42 because of the operation that your absolute value bars actually does. Okay, the problem that I want you to do as a group, okay, let's zoom in here a little bit. This is going to be your group problem. I want you guys to do this as a group. Pause the video, work the problem out, and then you can restart the video and see if you got your answer right. Your group problem is going to be the absolute value of negative 4a plus 1, close your absolute value, plus 4 equals 25. What I want you guys to do is I want you to pause the video, work it out, see the answers that you get, check your answers, okay, and then turn the video back on and see if you guys actually got the right problem. Okay, so go ahead and pause it now. Okay, so the answers that you guys should have gotten for this, one of them should be a fraction, which is okay. We can have fractions, we just don't necessarily like to work with them. You're going to get a equal to negative 5, and it's also equal to 11 halves. Okay, so those should be the two answers that you got for there. Hopefully that wasn't too tricky of a problem, but 11 halves is a legitimate answer, just like negative 5 is. Okay, so in total, there's all the work that we did, and you guys are now done with station number 2.